Our research title is all about computer lab access with face recognition. A computer lab access system cooperating facial recognition technology, it can also provide essential metadata, the course code, instructor, and presentation label. Introduction. This slide explains the system purpose and functionality. It's designed to be secured, efficient, and user-friendly. The core function is identify verification using facial recognition, ensuring only authorized individuals, students, and instructor can access the lab. It aims to enhance the overall user experience and create a software learning environment. Objective. This slide lays out the research objective. Accuracy and reliability assessment. The evaluate how well the system identify authorized user. Impact analysis. To study how the system affect lab access, efficiency, and workflow. User perception study. To guide student and instructor opinions on security and usability. Challenge identification. To pinpoint potential problem with implementing facial recognition in this context. Optimization. Recommendation to suggest improvements for the system and its deployment. Methodology. This slide outlines the research methodology. Research design, the overall research plan. Software development methodology, the process followed to create the system. Hardware and software requirements, the technical specification needed for the system. Data collection and analysis, the procedure used to gather and interpret data. Methodology. This slide details the research design for evaluating a face recognition system used for accessing computer labs at Isabel State University. The key takeaway is that the research employ a quantitative descriptive approach. This means the study will collect and analyze numerical data to understand user opinion and experience with the system. The goal it is measure how effective and well received the system is. The method will help gather numerical data to reveal user perception, including identify trends or common opinions. Statistical tools like average, standard deviation, and frequency tables will be used to interpret the collection data. This approach is for obtaining objective measurement for user satisfaction and system performance.
Software development and methodology. Number 1, analysis and quick design. Identifying user needs and creating an initial system design. Number 2, prototyping cycle design phase. Developing system prototypes and gathering feedback. Dito na yung mag-collect ng mga data. And number 3, testing. Evaluating the system for errors and improving functionality. This is where when the system need to evaluate of the respondent. Number 4, implementation. Deploying the system for actual use.
Hardware requirements. Face recognition system requires specific hardware components like processing capacity, memory, storage, and connectivity to effectively process images, identify faces, and compare them with a database providing a comprehensive breakdown of this component. For the system to function effectively, specific hardware and software are required. On the hardware sides, the minimum requirements include an Intel Core i3 or i3 for GB of RAM and a 256 GB HDD. However, for smooth real-time face recognition, we recommended using Intel Core i7 processors, 16 GB or more RAM, and a 512 GB SSD. Software requirements. A face recognition system needs some software components such as an operating system, programming language, and database to operate effectively. In terms of software, the system should run at least Windows 10, which Python or Java may be used, but Python with OpenCV and Django offers better integration. For the database, MySQL or PostgreSQL is acceptable, though Firebase or MySQL is more efficient. For facial detection is for Tense or Flow, or Keras with OpenCV is the ideal choice. Case diagram of the proposed system. For a student, attempt access using face recognition, view personal access logs. For admin, register new users, update or delete users' information. For view access log, monitor real-time access activity, override access manually, trigger notifications. And for system, detect and recognize face match face with database grant or deny access log. This use case diagram shows the interaction between users and the system. Students use face recognition to access the lab and view their access logs. Administrators register users, manage their details, and oversee system activity. The system itself detects and recognizes faces matches them against the database, and either grants or denies access while also logging each event. System architecture. The picture depicts a computer lab access system using facial recognition architecture, allowing users to verify their identities. The system includes a user interface, web server, and database for user information and access history. Administrators control users, while the system ensures secure authentication before allowing access. The system architecture consists of a user interface, a web server, and a facial recognition engine. When a user attempts access, the system captures their image, processes it, and performs feature extraction. The image is then compared to the face database. If match access is granted. Administrators can also monitor activity and intervene when needed. Respondents of the study. To gather feedback, we selected 100 respondents, 50 students, 30 faculty, and 20 administrators. This 50-30-20 distribution ensures that all users' perspectives are considered, especially those who interact directly with the system. This diversity of feedback helps validate the usability and practicality of our proposed system.
Computer lab access system using facial recognition architecture allowing users to verify their identities. The system includes a user interface, web server, and database for users' information and access history. Administrators control users while the system ensures secure authentication before allowing access. Respondents of the study. Respondents of the study targets respondents. Student is 50%, faculty 30%, and administrator is 20%. Pursuit and discussions. Gender distributions. Male is 58% and then the female is 42%, while the role distribution is student 65%, faculty is 25%, administrator is 10%. Age group 18 to 22 years old, 70%. Next is efficiency in access management. Mean 4.6, standard deviations 0.65. Faster authentication process compared to ID cards or manual logging. We also have system security perception. Mean 4.5, standard deviations 0.70. User feels safer with restricted access based on facial recognition. User satisfaction. Mean 4.4, standard deviation 0.75. Positive feedback on convenience and ease of use. Statistical analysis. T-test comparison face recognition system mean 4.6. Manual logbook method mean 3.1. P-value 5.89. P-value 0.001. Significant enhancement in lab access, speed, accuracy, and user satisfaction. Manual logbook 3.1, 1.0, and then 5.89. We also have face recognition 4.6, 0.8.
Summary of findings. The face recognition system achieved a mean accuracy rating of 4.7, indicating strong reliability in authenticating users and preventing unauthorized access. With a mean score of 4.6, the system significantly reduced time spent on manual logging and allowed for faster and seamless lab entry. User rate the system ability to prevent misuse of 4.5. Nothing increase confidence in the security of the computer lab. Conclusion. The deployment of a face recognition-based access system in the computer lab has been extremely effective, secure, and user-friendly. The system showed great accuracy in recognizing authorized users, cut manual entry logging time drastically, and enhanced overall access efficiency. Statistical analysis proved an overall significant improvement over traditional logbook methods, with user experience strong satisfaction in terms of convenience and security. These findings support the adoption of biometric access system as a modern solution for enhancing operational efficiency and safeguarding institutional resources. Recommendation. Number 1, in institution. Wide implementation. Owing to its high accuracy and efficiency, it is suggested that the face recognition system is implemented in all the computer labs and other secure buildings of the institution. Number 2, regular system updates and maintenance for continued reliability. The system must be subject to regular software updates, hardware calibration, and security audits. Number 3, user train and awareness. Hold short orientation sessions for student, faculty, and staff to introduce them to use advantages and privacy controls of the system. Number 4, backup access procedures institute backup access mechanism like ID card or OTP system. In, in exceptional instances of face recognition failure or when the system is down. 5. The data privacy and compliance comply with data protection legislation by protecting facial data, encrypting it, and restricting access to permit employees alone.